Good morning, all. I am Pawan. Today we are going to start first chapter of 9th class mathematics, real numbers. In the 9th class mathematics, first chapter is real numbers. Before going to the chapter real numbers, first of all, let us recall all the previous chapters of number system. We have learned about natural numbers, whole numbers, integers, fractions, decimals. What are they? Let us recall all the previous chapters, previous topics of previous classes. So, in the number system, first we discuss about natural numbers, whole numbers, integers, fractions and decimals. So, in the 8th class, we have learned about rational numbers. So, first of all, we start with natural numbers. Before going to natural numbers, first these numbers, all these numbers, positive numbers, negative numbers, fractions, decimals, all the numbers we found using digits. What are digits? There are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are called digits. Using these digits, we found different numbers. These different numbers are classified into different collection of numbers. Those are called sets of numbers, natural numbers, whole numbers, integers. These are collection. First of all, we are going to natural numbers. We are going to natural numbers. What are natural numbers? You all know what are natural numbers. But let us recall what are natural numbers. We generally say natural numbers. What are natural numbers? You all say 1, 2, 3, 4, so on. So, by the definition of natural numbers, all the positive counting numbers are called natural numbers. All the positive counting numbers are called natural numbers. That means set of collection of set of all the positive counting numbers. What are positive counting numbers? 1, 2, 3, 4. We count like this. 1, 2, 3, 4, 5, 6, so on. There is no limit for the numbers. So, we represent natural numbers with the letter n. We represent the set of natural numbers using n equal to set of. We call it as set of 1, 2, 3, 4, 5, so on. This means there is no limit for the numbers. The least natural number is 1. There is no highest natural number. The least natural number is 1. How do we represent these natural numbers on the number line? If you draw the number line, arrow mark, there is no limit for the natural numbers. But it starts with 1, 2, 3, 4, 5, 6, 7, so on. Are there any numbers before 1? Yes, there are numbers before 1, 0, negative numbers. Those numbers not included in the natural numbers. Natural numbers starts with 1. 1, 2, 3, 4, so on. These are the natural numbers. All the positive counting numbers are the natural numbers. If we join 0 to the natural numbers, that number set is called whole numbers. So, now we are going to next number set, whole numbers. So, next collection of numbers is whole numbers. Whole numbers. What are whole numbers? We already discussed what are whole numbers. Natural numbers along with 0. All the positive counting numbers along with 0. This collection of numbers are called whole numbers. So, all the natural numbers along with 0 or simply 0 are called whole numbers. All the natural numbers along with 0 are called whole numbers. So, we can say like this, all the counting numbers, all the positive counting numbers along with 0 are called whole numbers. We represent whole number set with the letter W. So W equal to set of 0, 1, 2, 3, 4, whole number? 0. 0 is the least whole number. There is no highest whole number. We can't say the highest whole number. There is no limit for the numbers. So 0 is the least whole number. How do we represent whole numbers on the number line? We draw a number line. There is no limit for the whole numbers. It starts with 0. 0, 1, 2, 3, 4, 5, so on. So we represent whole numbers starting from 0. So we start with 0. There is no end. So this is the representation of whole numbers on the number line. So we represented whole numbers on the number line. 0, 1, 2, 3, 4, so on. Are there any numbers before 0? Yes, there are negative numbers before 0. If we include negative numbers in the whole number set, along with whole number set, if we include negative numbers, that collection of numbers are called integers. So, if you extend like this, extend the number line like this, -1, -2, -3, -4, so on. That means natural numbers along with 0, along with negative numbers. This collection of numbers are called integers. So let us go for integers. So what are integers? The collection of whole numbers along with the negative numbers are called integers. That is, all the negative numbers, all the positive numbers along with 0 are called integers. So all the whole numbers along with negative numbers or negative counting numbers are called integers, the collection, the set. So you can observe here there are natural numbers, 0 and negative numbers. These are positive numbers, these are negative numbers. This is 0. 0 is neither positive nor negative. These are starting from 1, these are positive numbers, these are negative numbers, this is 0. So we represent integers with the letter, sometimes we represent with I. Generally we represent integers with Z. What is the relation between integers and Z? Z, we represent integers with Z. Z came from the German word Zehlen, which means numbers, the collection of numbers. Z, the letter Z came from the German word Zehlen. From this word it is Z. So Z equal to is the collection of 0 positive numbers and negative numbers. We write negative numbers from right to left. If we consider any number on the number line, right side there will be a big number, left side there will be a small number. That means if we take -2, -1 is greater than -2, -3 is less than -2, 3 is greater than 2, 1 is less than. If we take any number on the number line, the number on the right side is always greater, the number which is on the left side is always smaller. So we represent the integers with the letter Z. So in this collection of integers, there are positive integers, negative integers, 0. We represent positive integers with Z plus. That means 1, 2, 3, 4, 5. We can also represent like this positive integers and negative integers. We represent negative integers with Z minus. -1, -2, -3, so on. So positive integers, negative integers along with 0 are called integers. So if we represent integers on the number line, we represent like this. Positive numbers on the right side of 0, negative numbers on the left side of 0. We already discussed that. If you take any number on the number line, if you take 2, the number which is on the right side is always greater, the number which is on the left side is always smaller. The numbers, all the numbers which are on the right side of 2, 3, 4, 5 are always greater than 2. Which are on the left side are always smaller than 2. If we take negative numbers, take -2. The numbers which are on the -1, 0, 1, 2, 3, 4, which are on the right side are always greater. These are always smaller. That means minus 2 is greater than minus 2. You already know that. For example, if you take 3 and 2, which is greater? 3 is greater than 2. We represent like this. 3 is greater than 2. If you take 2, 3. 3 is greater. So we represent like this. 2 is less than. This is greater than, this is less than. If we take negative numbers, same negative numbers, positive numbers, 3 is greater than 2. If we take negative numbers, minus 3 is less than minus 2. That is, minus 2 is greater than minus 3. In the negative numbers, which are here 3 is greater, here minus 3 is smaller than, here 3 is greater than 2, here minus 3 is smaller than minus 2. Are there any numbers in between these 0 and 1, 1 and 2, 2 and 3? Are there any numbers in between these numbers? Yes, there are numbers. Which numbers? Fractions. The numbers in between the integers are fractions. If we convert fractions, there are different types of decimals. So first discuss about fractions. What are fractions? If you take 0 and 1, if we divide 0 and space between 0 and 1 into half, we represent this as 1 by 2 half. This is called fraction. These fractions are not included in the integers. Integers include only positive counting numbers, 0 and negative numbers. Fractions does not include in the integers. So 1 by 2. If we take a number in between 1 and 1 and half, this is a mixed fraction. You all know the types of fractions. Let us discuss the types of fractions. What are the different types of fractions? If we consider these fractions, what is that set? Let us discuss fractions. If we take 1 by 2 or 3 by 2, there is difference between these two numbers. If we observe here, this is called numerator, this is called denominator. Here numerator is smaller than denominator. Here numerator is greater than denominator. There are mainly two types of fractions. What are those two types of fractions? Proper fractions and improper fractions. Improper fractions can be converted into mixed fractions. So proper fraction, improper fraction. Here numerator is smaller than denominator. For example, 1 by 2, 3 by 5, like this. Here numerator is smaller than denominator. If you take improper fractions, numerator are always greater than denominator. Example, we take 5 by 3 or 7 by 2. If we convert these fractions, that means if we divide these fractions, we get different types of decimals. There are different types of decimals. In the chapter we will discuss how to convert fractions into decimals or decimals into fractions. But let us discuss what are decimals. There are different types of decimals. Terminating decimals, non-terminating, recurring decimals. What is meant by recurring? Repeating. What repeats? What repeats? A repeat. Particular pattern or particular number repeats. Here, another types of decimals, non-terminating, non-recurring decimals. Non-terminating, non-recurring decimals. There are mainly three types of decimals: terminating, non-terminating, non-terminating, recurring, non-terminating, non-recurring. If we divide these fractions, we get decimals. We can convert fractions into decimals. These fractions and decimals lies between these integers. How many fractions are lies between 0 and 1? There are infinite fractions lies between 0 and 1 and 2 and 3. There are infinite fractions and decimals lies between these integers. If we consider these fractions, decimals and integers, what is the type? What is the type of set? What is the collection? That collection is called rational numbers. Those collection of numbers are called rational numbers. But rational numbers contains only integers, fractions and decimals which are terminating and non-terminating. These non-terminating, non-returning decimals comes under another state, irrational numbers. So that means integers are not the final set. There are different types of numbers which lies between integers. There are different numbers, fractions, and if we convert fractions, that means divide fractions, they will be converted into decimals, terminating or non-terminating recurring, non-terminating, non-recurring. If we consider these fractions and terminating decimals and non-terminating decimals along with integers, those are rational numbers. Other than rational numbers are the irrational. Let us briefly discuss about rational numbers and irrational numbers. Then we go for real numbers. Now, rational numbers. We already discussed what are rational numbers. Rational numbers which includes integers, fractions, integers and fractions. So, fractions, if we divide fractions, it will be converted into two types of decimals. Only two types. Terminating and non-terminating. That means terminating, recurring. That means if we divide any fraction, we get two types of decimals, terminating decimals, non-terminating recurring decimals. You can again convert terminating decimals into fractions, non-terminating recurring decimals into fractions. That means the fraction form is called simply p by q form. What is p and q? Here p is numerator, q is denominator. We can take any integer. In the place of p and q, for example, if we take 3 by 5. In the place of p, we take 3. In the place of q, we take 5. 3 by 5. This is the fraction form. If you divide this fraction, we get the two types of decimals. Either terminating decimal or non-terminating recurring decimal. We don't get a non-terminating, non-recurring decimal, then we divide the fraction. We get two types of decimals, terminating or non-terminating recurring. This form, p by q form, the numbers which can be written in the form of p by q are called rational numbers. If we take 0.5, this is not in the form of p by q, but we can convert it to p by q form. We can convert it to fraction form. For example, if we take 2, this is not p by q form. This is a natural number. We can say this is a whole number. This is an integer. This is not in the form of p by q. If you want to convert simply by 2 by 1 means 2 or 4 by 2 means 2. This is not p by q. If it is not in the form of p by q, if we can convert it to p by q form, that number is also a rational number. So what is the definition of rational number? The numbers which can be expressed or written, which can be expressed in the form of p by q. What is p and what is q? What is p, what is q here? Where p and q are integers. There is a condition for q not equal to 0. What happens if q equal to 0? If you take a number p 5, q 0, division with 0 is not defined. It is not possible to divide any number with 0. It is not possible to divide any number with 0. You already learned in the previous classes. The denominator 0 is not defined. We can't find the value of 0. So the numbers which can be expressed in the form of p by q, where p and q are integers. P and q are integers. Q not equal to 0. So the denominator should not be equal to 0. Those numbers are called rational numbers, which are in the form of p by q are called rational numbers, which can be expressed in the form of p by q are called rational numbers. Let us see some examples. For example, if we take 2 by 3, this is in the form of p by q, so it is a rational number. If we take 3, Is it a rational number or not? We can convert it to rational number form 3 by 1 by adding by 1. If we write 3 by 1, it does not change the value of 3. 3 by 1 means simply 3. We can convert it to, we can express into p by q form, or we can write 6 by 2 value. 6, 2 divides 6, 3 times. Its value is also 3. So, if we can represent any number in the form of p by q, those numbers are called rational numbers. If we write 0.5, we can convert it to p by q form by multiplying with 10 and by dividing with 10. If you multiply any number with a number, we should divide the same number with the 10. That means 0.5 into 10, 5 by 10. So now we converted decimal into fraction form. You can also divide. 5 1 is 5, 5 2 is 10, 1 by 2. So we converted 0.5 into fraction form, p by q form. 5 by 10, 1 by 2. So we can convert all the natural numbers, whole numbers, integers, fractions and decimals, terminating decimals, non-terminating decimals into p by q form. So all the integers, fractions, terminating decimals and non-terminating recurring decimals comes under the collection rational numbers. These can be converted into p by q form. So these are all in the collection of rational numbers. Some numbers cannot be represented in the form of p by q. Which numbers? Non-terminating, non-recurring decimals cannot be converted into p by q form. Those numbers are called irrational numbers. Other than rational numbers are called irrational numbers. The numbers which cannot be expressed in the form of p by q are called irrational numbers. So which numbers cannot be expressed in the form of p by q? Generally non-terminating, non-recurring decimals cannot be converted into the form of p by q. The numbers other than rational numbers are called irrational numbers. Which are numbers other than rational numbers? Non-terminating, non-recurring decimals. If we convert any number, that means if we take root 2, you remember the symbol square root. Its value is a non-terminating, non-recurring decimal. So it is an irrational number, recurring, non-recurring, non-repeating. A particular pattern does not repeat. It does not end and does not repeat. If we take root 1, its value is 1. Root 2, its value is a non-terminating, non-recurring decimal. 1.414 so on. But does not repeat. Root 3, root 4. Root 4 value 2. In these numbers, it is an integer, so it is a rational number. It is a rational number. It is also a rational number. But these two values are non-terminating, non-recurring decimals. So these are irrational numbers. How do we know these values are non-terminating, non-recurring decimals? In the chapter we discuss how to convert the root 2 and root 3 into decimal form. So these are irrational numbers, these are rational numbers. So the numbers which can be expressed in the form of p by q are called rational numbers. The numbers which cannot be expressed in the form of p by q are called irrational numbers. Rational numbers are represented with the letter Q. Irrational numbers are represented with the letter Q dash or S. S means surds. Just we discussed root 2, square root of a prime number or square root of a non-perfect square number. Those are called surds. So we represent rational numbers with Q. What is the relationship between Q and rational numbers? Q means quotient. If we divide any number, we get a quotient. So it comes from the word quotient. Rational numbers are represented with the letter Q. Other than rational numbers, so we represent with Q dash. How to define rational numbers? There are numbers which can be expressed in the form of p by q or the rational numbers. So Q equal to set of, so rational numbers, Q equal to set of p by q. The definition is represented in the form of set, where p and q are integers. Q not equal to 0. This is the representation of rational numbers in the set form. Q equal to p by q, where p and q are integers. Q not equal to 0. Other than rational numbers are called irrational. So we discussed about rational numbers and irrational numbers. So first we discuss natural numbers. Natural numbers along with 0. This set is called whole numbers. Whole numbers along with negative integers. This set is called negative numbers. This set is called integers. Integers along with fractions, those are called rational numbers. Along with the fractions, those are called rational numbers. The numbers other than rational numbers are called irrational numbers. If you take all these rational and irrational numbers, if you take rational numbers and irrational numbers, all the numbers which can be converted in the form of p by q, which cannot be converted in the form of p by q. If you correct these two, those that collection of rational and irrational numbers is called real number set. What is real number set? The collection of all the rational numbers and irrational numbers, which can be expressed in the form of p by q, which cannot be expressed in the form of p by q. This collection is called real number set. So let us discuss this real number in the form of arithmetic. If we take natural numbers, if it is a collection of natural numbers, or 1, 2, 3, 4, 5, so on, and take the natural numbers along with 0, that collection is called whole number set. If we take whole numbers along with negative numbers, -1, -2, -3, so on, that collection is called integers. If we take integers along with fractions and terminating decimals and non-terminating recurring decimals, terminating and non-terminating recurring decimals, fractions, simply fractions, that collection is called rational numbers. So natural numbers along with 0, whole numbers along with negative numbers, integers along with fractions, that collection is called rational numbers. These are all can be converted in the form of p by q. These are all can be converted in the form of p by q. Natural numbers, whole numbers, integers and fractions can be converted in the form of p by q. The numbers other than rational numbers are called irrational numbers. This bigger collection of numbers which contains rational and irrational numbers is called real number set. So collection of all the rational and irrational numbers is called real numbers. Real numbers is the collection of all rational numbers q and irrational numbers q dash. So collection of all the rational and irrational which can be converted in the form of p by q, which cannot be converted in the form of p by q, which contains natural numbers, whole numbers, integers, fractions, decimals, terminating decimals, non-terminating recurring decimals, non-terminating, non-recurring decimals, all the collection is called simply real number set. This is the representation of Venn diagram form. Venn diagram. It is named after the mathematician Venn. This is the Venn diagram form. We can represent this real number set in the form of the flow chart also. Represent real number set in the form of flow chart. Real numbers. It is a collection of rational numbers and irrational numbers. Rational numbers is the collection of integers and fractions. Fractions can be converted into decimals, terminating decimals and non-terminating repeating decimals. Integers is the collection of whole numbers and negative numbers. Again, whole numbers is the collection of natural numbers and zero. So this is the representation of flow chart of the real numbers. So what are real numbers? It is the collection of rational and irrational, which can be represented in the form of p by q, which cannot be represented in the form of p by q. It is a collection of all the bigger numbers. So collection of natural numbers, whole numbers, integers. So you have to identify which number comes under real numbers, which number comes under rational numbers, which are natural numbers. For example, if you take 3. Is it a natural number or whole number or integer or rational number or real number? It is 3 positive quantum number, so it is a natural number. You can say this is a whole number, this is an integer, since it is a positive quantum number. It can be converted in the form of this p by q form, so it is a rational number. So all the rational numbers are a collection of real numbers. So 3 is natural number, whole number, integer, rational number and real number. So 3 we can consider in the form, in the set of natural or whole or integer or rational or real number. So you have to identify any number in which set we can write that number. If we can convert that number in the form of p by q, rational, cannot be converted irrational, that collection is real numbers. So assignment, define natural number set, whole number set, rational number set, irrational and real number set. Write 5 rational numbers. You have to write different types of numbers, which contains rational numbers, which can be expressed in the form of p by q. Write fractions and decimals, natural numbers, whole numbers.